Good afternoon as well. I won't take too much of your time. But first, we'll introduce ourselves a little bit. NSX is a spin-off company of the University of Antwerp, and it has been founded in 2011, and it is originated in normalized systems theory. And it sounds theoretical, but it's a theory on evolvable modularity, and it describes how you can make software that can evolve, software that can be predictable, software that can be truly sustainable, and software that can be rejuvenated and does not age. Now, that sounds like a dream, and so we created NSX to apply this, realize this on an industrial scale. And the purpose is to do that with lots of partners, sharing knowledge, having a community, and realize this dream of evolvable and sustainable software. Now, we consider ourselves to be a young and dynamic company because most of us are young, not all, of course, and we have innovative technologies. We also consider ourselves a mature company because some of us are not young, and because we have been in existence for 10 years, 11 years, but we have been profitable for 11 years, and we have been growing slowly but steadily for 11 years. And so that's why we consider ourselves to be mature. Now, what we do, we provide software development tools. We have our code generators, software development tools, and services to both public and private companies. But what we like most and what we are passionate about is that we co-create innovative software solutions with domain partners, other companies who have domain knowledge, who have dreams, who have innovative plans and ideas. And we have done that in several areas. We have co-developed, co-created a software solution for management and monitoring of sustainable energy in the residential market. We have co-created a privacy and security management software suite. We have co-created a suite in the area of real estate. So that's something we think is very important, co-create as a professional software partner, making sustainable, evolvable software with domain specialists. And so we are very proud that Helicus selected us as the software development partner for the C2C in those medical drone transports. So we do the C2C. And you have seen this lots of times. I show this again. We do the C2C. Not all of it. We are the software development partner for the C2C, not the operator, of course, which is Helicus. Now, you see at this drawing that if you do medical drone transports, you have lots of different things. You have medical transport orders, you have unmanned aerial vehicles, you have use-based service providers, and etc. But you need an integrated view of all these things. You need an integrated view, and integration in IT is always very difficult. And in this case, it's even more difficult. It is difficult because you have systems of different functional and business domains. And you don't only have different protocols, communication protocols, syntaxes, technologies that you have to integrate, but you also have to integrate different semantics, different concepts. Hospitals talk about samples, patients, fluids, medicines, etc. But use-based service providers talk about flight plans and airspace and authorizations. And unmanned aerial vehicles or drones, they talk about altitude, velocity, coordinates, battery charge, etc. So you have to integrate all these different concepts. And so a central system to coordinate that has to be aware of all these different concepts. It has to be technology agnostic. It must not be tied to specific technologies. You shouldn't see the technology. So that's quite a challenge. And if you look at it, and if we have done that, we have built such a system aware of these concepts and being technology agnostic and also shielding and encapsulating the various partners from the technologies of the other subsystems. Hospitals do not want to be aware about specificities of flight plans, specifics of unmanned aerial vehicles, about coordinates and velocity. They just need to know that it's a safe transport that is being done, what the status is, etc. And in the same way, USSPs do not have to be aware about any type of cargo that is being flown by the drones. So another thing you need to provide for is it should be possible to evolve and in the future having other new entrants in the unmanned aerial vehicles, other kind of drone manufacturers, which you cannot even imagine today. You should be able to have new kind of hospital information systems, healthcare systems to integrate with, new kind of use-based service providers, etc., etc. So, and that's why you need an architecture which is stable and extensible, and that's very, very important. You also need very solid, which I call firewalls between the various subsystems. You cannot have glitches, errors, strange things propagating from one subsystem to the other. You cannot have, for instance, that you cannot test one of the subsystems without using or impacting the other subsystem. So this is really an evolvability, a modularity challenge, and therefore it's really something that normalized systems theory and normalized system software was intended to do, and why we were very, very proud to be able to work with Michael and the Helicus team. So as part of SAFIR-Med, we developed this command and control system. And as you know, in software, nothing is ever finished and will ever be finished. But we come quite a long while. We have built this integration bus, and we have connected these various concepts, these business domains, these protocols. We have published and created stable interfaces for current and future service providers, use-based service providers, unmanned aerial vehicle service providers, etc. And we really have a technology-agnostic architecture, which is proven by the fact that we support 5 different drone types currently in SAFIR-Med with totally different autopilots. We have flown a couple of days ago with 4 different drones, I think, of different manufacturers at the same time, coordinated by the C2C. And this really is not a trivial thing, so we're kind of proud of it. Another thing, because it's based on normalized systems theory, software, we are able to evolve both the models, the flows, and the frameworks. You know, you need certainly in the course of several years in development, new kind of additional data that you have to manage and store and process, new kind of flows you have to support, new kind of flows due to regulations, due to different hospital systems, etc. So you need to be able to support that. Well, we do support that. We have done that a couple of times over the SAFIR-Med project. You need to be able security and framework upgrades, communication frameworks, security frameworks, persistency frameworks, etc., transaction frameworks, telemetry frameworks, because this is not a sprint, and this is a marathon developing such systems. Until there is a regulatory approval, until there are mature systems, until the market is there, this is a marathon. So you have to develop and continue development and maintenance over many years. And so if you start developing using certain security communication frameworks, they will be outdated by the time you're going live. But by rejuvenating, the C2C today is not old, it hasn't aged, it is still young, it has been rejuvenated over and over again. And so we do believe that we have developed a C2C together with Helicus, which provides a high level of testability, quality, safety due to the fine-grained modular structure, and that we will be able, due to our unique continuous rejuvenation, to ensure a stable product that will be sustainable in the long term and ever up to date and ever young, which we cannot be ourselves personally, but our product may be. So thank you. I won't take much longer of your time.